The goal of the summer jobs activity was for you to operationally define a construct that cannot be measured directly. Worker productivity is one such construct. To measure it, you need to measure other quantities, such as hours worked and dollars earned. Then, you need to develop a formula that tells how these measurements can be combined in a way that fits the notion of worker productivity. Other, operationally defined, constructs that will occur in this course will include distance, scintility, spread, chance, strength of relationships, and significance of differences. All of these are operationally defined constructs. And, in specific situations, the way you define them is one of the most important factors that strongly impacts the quality of results that you produce. This TinkerPlots worksheet includes data like the summer jobs problem that you worked on. But, this worksheet gives randomly selected data. If you want to see a new set of data, all you need to do is to use the pull-down menu for Data at the top of the worksheet. Then, select Re-randomize and you will get a new set of data. This worksheet shows 3 different ways that students often use to think about worker productivity in the summer jobs problem. The first method begins by first calculating average dollars earned across the 3 months, June, July, and August. Then, you calculate the average hours worked, or the total hours worked, across these same 3 months. Then, worker productivity is operationally defined by calculating the rate of average dollars earned divided by average hours worked. The second method begins by calculating dollars per hour for each month, June, July, and August. Then, worker productivity is operationally defined by calculating the average of these rates across the 3 months, June, July, and August. So, the first method averages first and then calculates a rate. Whereas, the second method begins by calculating rates and then finds the average of these rates. The third method, like the second, begins by calculating dollars per hour for each month, June, July, and August. Then, worker productivity is operationally defined by examining trends across the 3 months. Or, this third method might focus mostly only on performance during August, because some workers improved and other workers declined. So, August might be considered to give the most current information about the productivity of workers. Now, let's compare these 3 methods. One way to see how different methods lead to different results is to make a copy of one of the graphs, and to see how the results change if the attributes are changed. Notice how, for this particular set of data, the productivity of some workers appears to change significantly, depending on which method is used to define productivity. For example, if method 1 is used, then Sherry looks best. But, if method 2 is used, then Sherry is only average. Or, if method 2 is used, then Willie looks best. But, if method 1 is used, then Willie doesn't look as good. We can get more information about Sherry and Willie by using some other graphs. For example, the trends graphs at the bottom of the worksheet show that Sherry was only average in June. Then she was excellent in July. But, she was last in August. So, her productivity varied significantly across months. Similarly, Willie was only outstanding in August. Your first homework task for today is to randomize the data in this worksheet until you find a case where some workers' productivity appears to be significantly different, depending on how productivity is defined. Then, pick a worker whose profile of productivity appears to be interesting in this data set, and write a 1-page explanation of this worker's performance across June, July, and August. To copy graphs into your report, select a graph and then go select Copy as Picture under the pull-down menu for editing.